Hello, my dear students. Today, I am going to explain the characteristics and constitution of camphor in the terpenoid series. This compound is bicyclic, monoterpenoid, and cyclic ketone. This compound is solid, having melting point 180 degrees centigrade, and the dextro and levo form of the compound is isolated naturally. It can also be synthesized in laboratory, but synthetic camphor is mainly obtained as a racemic mixture. This is a very important compound. First of all, I will try to discuss the constitution of the compound. The established molecular formula through the elemental analysis and molecular weight determination is C10H16O. C10H16O. The compound C10H16O neither adds bromine nor the compound is able to give the Bayer's test. No adduct, no decolorization. By using these tests, we can say that carbon-carbon double bond or carbon-carbon triple bonds are absent in the molecule. Number 3. The compound C10 S16O, when allowed to react with hydroxylamine, it gives oxime. When allowed to react with phenylhydrazine, the compound gives hydrazone. When it is allowed to react with semi-carbazide, we will get semi-carbazone. These reaction indicates that our compound contains a carbonyl group. So it is a carbonyl compound. It is a carbonyl compound. This carbonyl compound, C10S16O, is unable to respond Tollens test, fails to respond Fehling test, which confirms that this carbonyl compound is not an aldehydic compound, so it is a ketone. So our camphor is ketone. It is ketonic compound. When this ketonic compound is heated with concentrated nitric acid, it gives a dicarboxylic acid without change in carbon. The formation of dicarboxylic acid from a ketone confirms that the ketonic group is present in the ring chain. Now consider ketonic group in an open chain, when a ketonic group is present in an open chain, it is converted into monocarboxylic acid with lower carbon And when the group is present in a closed chain, it is converted into dicarboxylic acid without change in carbon. So the oxidation of camphor with nitric acid into a dicarboxylic acid confirms that the compound is a cyclic ketone. Cyclic ketone. The unsaturation factor for the compound is 3. As we have seen that we have a carbon-oxygen double bond which compensates one as unsaturation factor. I have earlier proved that neither double bond, carbon-carbon double bond, nor carbon-carbon triple bond is present in the molecule. On the basis of these 3 reactions, we can finally say that this compound is bicyclic. Is bicyclic. Without multiple bonds, without multiple bond, carbon-carbon multiple bond. So this camphor is cyclic ketone and it is bicyclic. When this compound is reduced with iodine, it is converted into a phenolic compound and it is called carbacrol. And when it is heated with anhydrous zinc chloride, a dehydrating agent, it is converted into paracymene. The formation of these benzenoids indicates that this bicyclic compound has a 6-membered ring in addition to another type of ring. That is, अगर ये bicyclic compound है then it must have one 6-membered ring, which is finally converted into aromatic ring. When this compound C10H16O, that is camphor, is allowed to react with sodium nitrite HCl at low temperature, it gives an oxime. Through iso-nitroso camphor. So first, camphor is converted into iso-nitroso camphor when allowed to react with sodium nitrite HCl at low temperature, and on tautomerization it gives an oxide. This iso-nitroso camphor, when tautomerized into oxime, it can give a diketone. This reaction is characteristics of a compound in which ketone group is attached with CH2 unit. CH2 unit. When a CH2 unit is attached with ketone group, the tautomeric form, this tautomeric form is also present in the compound in situ. NaNO2, when allowed to react with dilute HCl, it produces nitrosonium ion. An electrophilic addition takes place. To produce this is iso-nitroso compound. Which on tautomerization will produce monooxime, and this monooxime on hydrolysis gives diketone. The formation of diketone by camphor through this reaction confirms that the carbonyl group is directly attached with a CH2 carbon. So, from the above reactions, we have conclusion that camphor is bicyclic, in which ketonic group is present, ring carbon, and this ketonic group having this constitution. It has also a 6-member ring. Six-member ring. In order to establish the complete image of camphor, the degradation of the compound is essential. Degradation of the compound is essential. Now, oxidative degradation. Oxidative degradation. The camphor, the compound, the said compound, when heated with concentrated nitric acid, it gives a dicarboxylic acid and this dicarboxylic acid is identified as camphoric acid. This dicarboxylic acid, when brominated or when it is further oxidized and strongly heated, it is converted into tricarboxylic acid. With the loss of carbon dioxide. And this tricarboxylic acid is identified as camphoronic acid. Camphoronic acid. So in my next lecture, I will try to establish the structure, first a structure of camphoric acid, then camphoronic acid, and these two structures I will explain the structure of camphor, and the structure will be finally confirmed by the synthesis of the compound. Thank you today.